You said that a little while ago. Remember the first time tell my mother say, "Me have girlfriend." I me tell her who. She say, "You sure that is the right person?" No, if you know that. No. Anyhow, back to this. So we have to find the eigenvalues. So question, anybody remember how to find eigenvalues?
So I think you multiply by the identity, no, what do you call it, unit matrix or something like that.
All right, so what we have to do is solve equation. So you had the idea, multiply, I'm putting lambda I minus A equal 0. As I've been telling persons over the years, the way that you guys learn maths and the way that if I did learn maths the way that it would have been, I would have failed every maths exam. As I mentioned the word eigenvalues, this is the only thing in my mind. That is the only thing. Want to find eigenvalues? Solve this equation. Lambda I minus A to determinant equals 0. We know what is I, we know what is A, lambda is a constant, I know how to find determinant, and whatever I end up with, I will take it from there. Oh, we're gonna learn maths the American way, which you can subscribe to. And it makes maths kind of a little bit, to me, it makes maths a little bit more difficult. And by the way, somebody might be asking, what is the American way? The way American way is the way you learn maths. Let me illustrate. Somebody explain how you solve this equation.
Use a quadratic formula.
All right. That's not the American way.
I guess I've never learned it the American way.
Multiply this C by the coefficient of A.
All right. So you see what you say? That is what I mean by learning by the American way. You learn it in American, learn how to solve maths in an American way. First answer was use a quadratic formula. That's a blanket statement. So would I forgot get the quadratic formula, know how to use the quadratic formula, put in the thing them inside here, start it out. Second statement that was made was multiply C by A. So what you're supposed to be saying to me is that you have to factorize it. So when you say multiply C by A, what that is doing, you write down to a specific set of routines. There's an algorithm you have in your head. So it's not a broad overarching thing. So, oh, I have to factorize this. Because like me, not factorize by multiply C by A. So when me sit down in a class, I used to say, well, if I multiply C by A, and I say, what that? What am I say? Right? So I want you to, whenever you look at these things, remember the overall thing, not just specific. Multiply lambda by I and you have to go do it. Don't remember, it's the details that you don't remember it for the maths. It's not the details that you must remember. You must solve this equation that is here now to find the eigenvalues. Right?
To be honest, or coming. To be honest, I can't really work with it the specific way, the A times C times whatever. I use the quadratic formula all the time.
No,
we use them all the time.
All the time. So that's what I'm saying. When everything in maths and engineering, use an overarching principle, not a specific. Because the C time A is basically what is called, the method is called factorizing by splitting. So in other words, when you say multiply C by A, you don't know what you do. You just know say you have to do something and it will give you an answer. And that is what we want to eliminate. So you know how to do something to get an answer. No, just learn our overarching principles. So like this now, I say find eigenvalues, solve this equation. So is lambda, do you know what is I? Identity matrix.
Yes,
We
sir.
know what is A.
1001.
1001. So now this here is the equation that I must solve. So we keep the so it is going to be lambda 2301 minus, sorry, 230 must go here. So we're going to simplify this. So to simplify this, I multiply lambda by inside here. So that's lambda 0, lambda. And then this is 2301. And then is lambda minus 2, 0 minus 3, that is minus 3, 0 minus 0, that is 0, and lambda minus 1, that's lambda minus 1 equals 0. And then the determinant. So I'm going to multiply across, and multiply across and subtract. So that's lambda minus 2, lambda minus 1 minus 0 times minus 3 is equal to 0. That is the lambda minus 2, lambda minus 1 is equal to 0. So lambda equals 2 and 1. All right. So ability to find eigenvalues is important in all branches of engineering. Whichever branch of engineering you are in, if you're in electrical engineering, then the finding the eigenvalues of a matrix. If you model a system and you end up using you modeling it using a matrix form, then the eigenvalues will do things about the stability of the system. If you're in mechanical engineering, and you're finding eigenvalues, it will give you, if it's something in materials, then it will give you the strongest points in the material, and then the eigenvectors will tell you which way you have to apply the force to break it. There's a whole range of different things. Eigenvalues and eigenvectors give you a whole range of things. But we're not dealing with that right now. We're just dealing with the process of finding eigenvalues. So it's solve lambda I minus a, the determinant of that equals 0. All right. Now, so those are two eigenvalues. So the second thing that we have to is find the eigenvectors. Just write by the matrix here. 2, 3, 0, 1. So how do we find the eigenvectors?
So substitute the values for lambda in.
All right. So let me watch in thing. We're going to solve AX equal lambda X. So we're going to solve 2, 3. And by the way, that is all that is in my hard drive about eigenvectors and eigenvalues. The first thing right now, solve to find eigenvalues, solve that. The second thing, to find the eigenvectors, solve that equation that we have here now. So 2, 3, 0, 1. I should write x1 and x2, but sure, I write it xy is equal to lambda. And so I'm going to use the first eigenvector, which is a 2. And whenever we are doing this, we always end up with an equation that is singular, or an equation that is I don't know what to use the word dependent, or I use the correct maths word. But what about this time? I'm going to get y equal 2y and 2x plus 3y equal. Now, so you always end up with some linearly dependent equation. So now, the second equation is kind of redundant. There's only one value of y that is going to make y be equal to 2 times y. What is that value? Education, people say we must count to 3. And then we get brilliant answers. So we'll count to 3. 1, 2, 3. So tell me what.
2, sir.
Sir, 2.
No.
3.
3, no,
0.
sir. 3.
0.
Yeah. No.
So it's the only solution is y equals 0. So now, if I substitute this y equals 0, I'm going to get 2x plus 0 is equal to 2x. So any value of x, because 2 times x is equal to 2 times x, any value of x I choose will work. So, of course, so I choose x equal 1. So therefore, I can choose x equal 2, I can choose x equal 3, I can choose x equal 4, etc. So the first eigenvalue that I have is x is equal to 1, y is equal to 0. And then I'm going to put in the next eigenvalue for lambda, which is 1. So I'm going to solve the next equation that says 2, 3, 0, 1. Xy is xy because lambda is 1. So
Sir, go to page the
I didn't
page 62. Alright, sir, can move on. Alright, sir, can move on.
All right. So let me put the one there. So it's 2x plus 3y equal x. and we have y equal y. So if y equal y, that is redundant. We can choose any value of y because y must equal y no matter what I choose. So choose y equal 1. And then I will substitute that back in here. So that is going to give 2x plus 3 times 1 is equal to x. So therefore, I'm going to carry over the x. So that's 2x minus x is equal to minus 3. So x is equal to minus 3. So the next eigenvalue is x, y is equal to negative 3, 1. So the two eigenvalues are eigenvectors, sorry. All right, so the key to remember is that if you find any eigenvalues, eigenvectors, then eigenvalues just have lambda I minus a equals 0, the determinant of that equals 0, and eigenvectors just have ax, where a is the matrix, and x is just the vector, xy is equal to lambda x. And you proceed. So we go up to there.
Yes, sir.
Okay. So let's now say how we find the function of the matrix. So for our matrix A,
So that's number 3.
so now I'm just making a statement about a function of a matrix now.
Okay.
And there we go. So if I want to find any function of the matrix, whether sine of the matrix, cosine of the matrix, e to the matrix, log of the matrix, a to the whatever it is made up of you're going to multiply 3 things. P, and I also explain what P is, P and P inverse. So P is the matrix formed by using the eigenvectors. So our P in this case is going to be, first one was 1, 0. The second one was negative 3, 1. So that is P. And so let us just find P inverse. Inverse of a matrix.
Hold on there, sir. What's that symbol between P and P inverse?
D, as in Darren or dumpling.
So P, D, P inverse,
Yes.
and that stands for what?
So now I'm explaining what, so I'm just explain the P, and I'm going to just find P inverse same time. And then I'm going to explain what the D represents.
All right, sir.
All right. So I'm going to put it up here. If I have a matrix equal A, B, C, D, then what is A inverse equal? Well, it's one of
one of the determinant times the matrix.
Yes, and
Yeah, that. I don't know what to call that.
what do you call it? The transpose of the matrix of cofactors.
That, yes, sir.
yes,
Yeah,
sir.
learn that you sound impressive when you say it.
Go again, sir.
The transpose of the matrix of cofactors.
So you just negate B and C and switch A.
No,
No,
yeah,
man,
because
that make you sound.
transpose
I'm
of
saying,
Yeah.
I'm saying that you need to sound intelligent.
Yes, sir. We
No, I
understand, sir.
switch on no, I go tell
you have
everybody.
to say transpose of the matrix of factors.
Cofactors. Right.
Cofactors, sir.
Cofactors. Anyway, when you go back up everybody over from some other university. Oh, I need to find the inverse. Oh, just find the transpose of the matrix of cofactors. They say, what am I talking about? Sound very bright. Yeah, but they switch around the two things, them and they minus that. You work it out better. So P inverse is 1 over, multiply these two. 1 times 1 is 1, minus 0 times negative 3. And then now, switch them to your own, 1 and 1, and find this and this, or positive, change the sign on these two. So it is going to be equal to 1, 3, 0, 1. Okay. All right. So any form matrix, the function of the matrix is this here. And so we say P is the matrix that is formed using the eigenvectors that you have, and D is the diagonal matrix. So D write it down and then say what it is using the eigenvalues. So, all right. So D now is going to be equal to, in this particular case, is a diagonal matrix formed using, you're going to replace whatever A is with the lambda 1 and lambda 2 in the matrix. So an example will serve better than my talk. So we want to find f of A equal
Sir,
E.
can you go back a minute, please?
Okay.
Sir, we can't really see the bottom part of the screen, sir.
All right, but I'm partner really relevant. But I write it back over after we go over the next slide. But in there,
All right.
And check to make sure you're not zoomed in or anything.
All right, sir, can I take on the road?
all right. So we need e to the at. So now my d, what I'm saying is going to be equal to, you're going to write back the thing same way. And the first, instead of a, you're going to put the eigenvalue 2t 0, 0. And on the next diagonal, you're going to put e to the 1t. So that is the diagonal matrix. So e to the a t is going to be equal to p d p inverse. Let me just look and see what it's here again. 1, 3, negative 3, 0, 1. this is 1, -3, 0, 1. And over this side, it is 1, 3, 0, 1. So a to the at, we're just going to multiply with this. 1 times e to the 2t is e to the 2t. 3 times 0 is 0. 1 times 0 is 0. So over this side is minus 3e to the t. 0 times e to the 2t is 0. This is 0. And 0 times 0 is 0. And plus e to the t. So that's e to the t. As 1, 3, 0, 1. So e to the 2t times 1 is e to the 2t plus 0. E to the 3t is 3 e to the 2t. 3e to the t times 1 is going to be minus 3e to the t. 0 times is going to be 0 here. And 0 times 3 is 0. E to the t times 1 is e to the t. So that is my e to the at. So my diagonal matrix is the function with the eigenvalue replacing the actual a. So that will be my e to the a t. So let me just put a to the 10th over here. That's 1, -3, 0, 1. And then this is going to be
2 to the 10. 1 to the 10.
multiply it out, that's 2 to the 10. -3 times 1 to the 10 is 1 to the 10 is just 1. 0, 0, and 0 times 1 is 1. So it's 2 to the 10 times 1, which is 2 to the 10. Time long ago, I don't know what 2 to the 10. 32 squared is much. Whatever. 2 to the 10 times 3. All right, so you get the general this. All right.
Yeah.
Mhm.
equipment kind of cut off. The element in the last matrix. But that's
Oh,
2
let me
to
put
the
it up.
10.
2 to the 10. Let me put it
Yeah.
up here. So. Two to the 10, 0. 2 to the 10 times 3 minus 3. Work it out. Or 1. I'm supposed to carry for that 32 squared times 3 minus 3.
And 24.
So what I'm going to do is do the same thing in MATLAB. And explain to you why the answer is going to be different. All right. So the matrix A in MATLAB, here we have a MATLAB script. So matrix square bracket 2, 3, wait, tell me that. Sure. I didn't go to the UTech one. All right, so A is equal to square bracket 2, 3, 0, 1. Okay. So now, if you want to find the eigenvalues of A, just to be, I'm going to say x is equal to EIG A. EIG represents the eigenvalues. So C gives me 2 and 1. We want the eigenvectors now. I'm going to type in V, oops, V D and that's equal to EIG A. It's going to give me the eigenvalues, and the D is going to give me the diagonal matrix with the eigenvectors, and the V is going to give me the eigenvector matrix. All right, now, so let me explain something. first eigenvector is this one here. So is 1, 0. The next eigenvector that you have there says 0.9487 and 0.3162. But if you recall, our eigenvector was -3, 1.
Sir, it's just the same number simplified out.
All right, so let me tell you what MATLAB does. This is called normalize. The two of them is normalize. So if you at some point in your maths you're doing vectors, what you do is take, you see the same 3, 1 here, you find the length of the vector, which is -3 squared plus 1 squared, and that is equal to square root of 10. And then what they did is that the lambda 2 is equal to -3 divided by root 10 and 1 divided by root 10. Let me see if that gives me the. So they normalize the vector. So that's -3 divided by, I'm working it out on the calculator, divided by.
Yes, sir.
Okay. So the normalized vector is a vector divided by its length. So MATLAB is going to give you some numbers that are weird looking to some. And see the eigenvalues here, the diagonal with the eigenvalues, see them here. 2 and 1.
So, sir,
Mm-hmm.
if you use MATLAB and get that value, how would I get back to the one that we worked out, sir?
You won't.
All right, sir.
Sir,
Mm-hmm.
just looking at the numbers, if you divide 0.9487 by 0.3162, it kind of carries back to what we got in a sir.
Right. I just realized. So your question was answered before. Take the smallest value and divide it into the other values that you get, and it will carry back to some nice normal numbers.
So question, sir. Multiply it by the what I call it now, modulus, sir. Wouldn't give you back the.
Yeah. If you find the modulus or the length, then it would, multiplying it back would give you back. Because if I multiply this by root 10, I'll get 3. If I multiply this by root 10, I'd get 1. So that would also work. All right. So you can just use this command and get your eigenvectors and your eigenvalues. So you can use those and do your calculations and aid you with your calculation. So we're talking about all these things. Let me just digress. The little time that I was in China, I was in Wuhan, China.
Before COVID or after COVID,
Before
sir?
COVID, long before. Well, not long before.
Oh, all right, sir.
So, and I was at they had asked me, well, they had asked me, one of the youngsters in the who was at UTech, they get a scholarship to that university to go do a master's. And then they asked in the class if they knew anybody from their home country who would be willing to come and teach a course in China or during the summer. And he put up him on and called my name. And then he emailed me and tell me, say, put up him on and call my name. I said to him, Regine, wrong name. You never see me jump yet because I don't want to stay airborne that long. And him say, no, just lucky I am come. He said, Bridget, I don't take planes. I'm not going anywhere. Me keep my feet on the ground. And he said, come, all you do, take the plane, lock your eye, and do the same thing when you put food in front of you. Now ask the question. Just eat it and don't ask the question.
That was so
Sir, eat
sir.
dog and
So
them thing
you're
there,
like,
sir.
yeah, it's so long, sir.
Huh?
Yes, sir. Eat dog and them thing there. I don't know.
I don't know. Never ask the question.
All right,
Sir.
sir. That makes sense.
So, oh yeah, engineer afraid to fly, sir.
How me an engineer afraid to fly? That's why I'm afraid to fly.
Exactly. Yeah, engineer, you're free to
Because
drive.
engineer is
Exactly.
afraid to fly. You see me? You know exactly what going for the plane. You see me? Or something like that, man.
Yeah, man.
That's why sir, I teach, you know, the aviation. Tell him
No,
no, sir.
sir. No, behind the painting. No. When the plane was there for 6 hours, it reached, well, I didn't know longer, meetings it's supposed to land by now. So we asked the air hostess, say, so when we land, she said, another 6 hours. We said 6 hours more. You're mad.
Oh, 14 hours flight, sir. Or 30.
Yeah.
30.
14, 12 to 14, depending on which way you go.
Yeah, where you going?
But
So
anyhow,
when you sleep, you wake up, you sleep again.
no, I can't sleep.
You just can't always sleep the flight.
You best have been sleeping, sir. You never up on a long fire, sleep.
No, I can't sleep.
Sir, takes on DPH, sir.
That don't work. And coming back is traumatized, but that is another story for another day, another audience. But anyway, the reason why I was saying this now, when I went there, they said, the lecturer, one of the lecturers there, it was Central China Agriculture University. So it kind of, how China do them thing is they all of the virus and biology in one city, Wuhan. They study all of the business in one city, Beijing. That's why they don't study business in Wuhan, but everywhere turn is some virology, biology, biochemistry. Even the university that was that they did engineering, but everything was biology based or chemistry based or no, not chemistry based, biology based. Everything was so mechanical engineering. They did do whole heap of biological things inside here. So that's why I was surprised when me said the virus broke out from Wuhan. Because that is where all of the virology is being studied. Anyhow, so all of that before what I just said is that when I reached and it was talking to the lecturer, it was saying that if anybody, anybody from UTech who, especially if they know MatLab, we'd love for them to come over here. Because the MatLab is, if you're looking at the screen, you see in pure English. There are English signs. So the Chinese needed people to help them interpret all of these things. So they were quite happy.
You speak Chinese, sir?
No, it's only 2 words we did for try.
So, sir, how you did bring across the information to them?
English.
Still, obviously, man, them talk English still.
No English much, you know.
See it there? See it there?
That was
But
part of
sir,
the
we're
Because
not
if they
teaching
didn't if they
universal,
didn't know
sir.
English, they wouldn't need, sir.
But sir, we're
part
not
of
teaching universal.
huh?
Universal language.
Well, the Chinese have a particular problem with English because what happens is that after 12 years of learning English, are forcing everybody to learn English, and then they teach some of the lectures in English. So that's what I was there for. Not for the content, but to teach the content in English so that they get used to hearing English. But after 12 years of high school and school, primary and high school, and 4 years of college, where they're learning all of this English, at the end of it, they don't know nothing. They don't know any English. But
Good,
so, but me did only learn the racist word them in a Chinese to say any of them did not say that. But they did sit down and study all of those.
Yes, sir, that badness it name. That bad up down in China.
But the one joke that did happen in our class is that because we said we look up all of the racist word and analytics. I was woke up, this comedian was talking about his experience in China. I said the Chinese word for meaning say when I'm talking, I say you know, the pause in the sentence. When the Chinese say them don't say them say nigger. So everywhere them talk to another they hear say nigger.
It can also mean that.
Yes, so them stay.
So
yeah,
so we did put a girl up on the board to explain one of these things that we were doing here. And she was trying to explain it, and she must explain it in English. So she was thinking, and she did that nigga. And you see the whole of them Chinese people easy for shame. Apparently them tell them, say, do not say that in front of a black person. So when she did that nigga, you can see the host lecturer there, like I said, no, stop it. And the more I tell her no, the more she said nigga. And all of them, of course, they laugh, but them, like I said, them easy for shame. So, poor thing there. But like I said, learn MATLAB, it will be useful. They want to learn MATLAB and use it in a theory. All right. So we could go back to so if I wanted to find, for example, clear the screen. So now if I wanted to if I had a circuit or whatever it is, and I wanted to find the eigenvectors and eigenvalues. So let us say that this circuit works out to A equal, and let's use so these are the values in the circuit. And I wanted to find I wanted to find the eigenvalues and eigenvectors. So it would be A
Sorry, you sure you don't want to use a different variable name so you don't overwrite the A that's already there?
All right, this B. So that's B, 2, 3, 4, 1, 0, 2, 5, 7, 5, 1, 4, 3, 2, 5, 6, 1. Okay, so we would put in the V let me call it not V, but P, because that's what we've been calling P, D, equal EIG B. So columns here are the eigen vectors and the eigenvalues are shown there. Now this one here makes sense to take it out of normalization because we still end up with a decimal. So the eigenvalues there in the diagonal are all decimal places. So we just wanted to share that is how we find the eigenvectors, eigenvalues in a matrix. Okay, so now the last thing, because we just sometimes when too much is said, mother always say when much is said, little is retained. So what I would want you to do okay. All right. So the last thing that I'm going to talk about tonight is I'm going to give you this as a small assignment. I want you to write down the differential equation, find the eigenvalues of the system. Now, here's how you find the eigenvalues of the system. The eigenvalues of the system, let me write it up here in red. So your eigenvalues of your system are the roots of your auxiliary equation. So I wanted to write down I want you to write down the differential equation, then find the eigenvalues of the system, solve the differential equation, all of these things using MATLAB. So I'd like you to do that.
Sir, you could read the last part of the question for me, please.
Oh, shoot. Forget. Solve the differential equation using MATLAB.
Thanks.
All right, so solve the differential equation using MATLAB. Find the eigenvalues of the system using MATLAB. All right. So I wanted to do that as an assignment and email it to me.
I went so.
Sir, say that again, sir.
You just do it as an assignment and email it.
By when, sir?
I'm thinking.
Next week, Thursday.
Whoa! wait. Next week Monday.
We have some deliverables this week. That's what I said.
All right, next week Monday. Next class. Next Monday.
Sir,
class.
All
right. How do I get MATLAB, sir?
All right. You have a UTech ID?
Yeah, I have a UTech ID.
So if you have ID, then
Yours or mine, sir?
yours.
Yes, I have one.
Email?
The email was set up.
Well, it's because UTech has access to MATLAB. But if I said this that I'm using here is the I just went to MathWorks and signed up using my non-UTech email. And then say I wanted a 1-month trial. And then I download on my computer. I said that I will use the browser. But you can download it to your computer, so you don't have to be on the internet for you.
All right, sir.
Sir, what is that? Darren.f?
Darren underscore F.
Oh, underscore.
Oh, sir. Oh, open MATLAB online. Okay.
But if you have
Sir.
your
In the beginning, sir, I saw you have a function with sine A, sir. I never saw you do that part in the workout.
Okay. So the sine A, it would be the same. Let me just put it over here. So sine A would be equal to 1 negative 3, that is it, P, 1 negative 3, 0, 1. Sine of 1, sine of, no, that's sine of 2. Eigenvalues have to be in the right place. 0, 0. 1, 3, 0, 1. So if you are seeing the screen?
Yes, sir.
Yes, sir. I see your screen.
All right. So so when you multiply out that, the sine, the 1 and the 2 and the 1 would have to be radian. It wouldn't be degrees. So we would multiply it out. So that's sine 2. This is 0. 1 times 0, 0, minus 3 times, that's minus 3, sine 1. This is 0, and then this is sine 1. So it's going to be sine 2, 3 sine 2 minus 3 sine 1, 0, 0, 3 sine 1. And then, where did you could have put this in a MATLAB and it would work out all of the values. So you look up sine of 2, put it in radians. So according to them, is 0.910, 0.84, yeah, 3 sine 2. It will be 0.91, 0.2, 0, 0. So that would be your sine A. All right, so like I said, Thursday we talk about writing a differential equation as a matrix, and we look at 2 examples of finding of using all of these things here. So mod losses. All right. So
What is it, sir? Thursday, sir?
what time we have class on Thursday again?
5.
5. Because I'm supposed to carry. Supposed to go to a funeral in the country. Clarendon.
So, sorry, when did I say it due? Thursday? Next week Thursday or next week?
Next week Monday.
Mm.
If we can get back from the funeral in time, they use the time and do the assignment.
All right, sir.
Okay, sir.
All right.
Monday, I say I go funeral, sir.
Thursday.
Oh.